download. All right. I'm going to share my slides now. Can you see my chapter 4 slide, first page?
Yes.
Okay. We go now. We go now chemical reactions. We describe how to write chemical equations, how to balance them. And we mainly focused on chemical reaction that take place in water solution called aqueous solutions. We talked about precipitation reactions and acid-base reactions, gas formation reactions. Now we're going to continue where I started, which is on oxidation reduction reactions. From there, we move on to stoichiometry later in the class. Let's start from oxidation reduction, redox reactions. Precipitation and acid-base gas formation reactions doesn't involve electron transfer between atoms of the compounds undergoing chemical reaction. Therefore, they are different from this class of reaction where electron transfer take place. These type of reactions are called oxidation reduction reaction or redox reaction. In oxidation reduction reaction, oxidation means loss of electrons. If an atom in a compound loses electrons, that atom is undergoing oxidation. If an atom gains electrons, it is reduction. How do you remember this is using this mnemonics. Leo says the Leo stands for loss of electron is oxidation. G means gain of electron is reduction. If you look at the reaction between zinc metal are neutral atoms. Zinc metal react with copper ions, like in copper sulfate solution. If you dip a zinc plate in copper sulfate, zinc donate 2 electrons to copper, 2+, and copper become copper 0. That's a copper metal. In this reaction, if you look at the reactants, zinc is being oxidized. Copper 2+ is being reduced. Copper 2+ get reduced to zinc get oxidized to zinc 2 plus. Therefore, there are two things happening in electrochemical reaction or oxidation reduction reaction. There's a species, zinc metal, is oxidized. Copper ions in the copper sulfate solution is reduced. So we can describe this in little more detail. When reactant, one of the reactant in the reactant side is reduced, it can oxidize another reactant. Therefore, this is called, one that get reduced is called oxidizing agent. This is also true. If a reactant in a redox chemical reaction is oxidized, it's called reducing agent. This is because oxidation and reduction take place simultaneously. Therefore, one gets reduced, this one, oxidize another reactant. Therefore, it becomes the oxidizing agent. This is kind of opposite of what they are undergoing. Agent is what they're doing. Same reaction. Zinc is oxidized. We talk about that. Loss of electron. Copper is reduced. Therefore, whatever the species in the product side, reactant side, copper is reduced. Therefore, it helps to oxidize zinc. Therefore, copper 2 plus is an agent that helps to zinc to get oxidized. Therefore, species that got reduced is called oxidizing agent. Right here. Opposite applies to copper 2 plus. Copper is reduced. Therefore, it is the reducing agent. So we ask questions to figure out whether you understand process of oxidation and reduction. We also ask questions about what is the oxidizing agent and reducing agent in redox reaction. Let's answer a few questions about these things. Which of the following oxidation, definition of oxidation is most useful dealing with ionic compound? Ions like zinc goes to zinc 2 plus. When you have ions involved, ionic compounds involved, therefore directly we can show the gain or loss of electron. Therefore, for ionic compounds, which applies? For ionic compound, oxidation is gain of electron. That's not true. Oxidation is loss of electrons. That is true. Okay. Oxidation is loss of hydrogen. We didn't talk about loss of hydrogen. Later, we're going to talk about when you describe oxidation reduction reactions in covalent compounds. Loss of hydrogen is used as a way to describe the oxidation or reduction. Therefore, none of these is not true. The correct answer is B. In ionic compounds, oxidation is loss of electrons. Reduction is gain of electrons. They didn't talk about reduction here. If you look at this equation involving lead metal, first one is lead metal, silver, aqua silver ion. This is kind of net ionic equation for the redox reaction. You can put chloride ions, two of them, to balance the silver. And silver chloride also have missing chloride ion. Chloride ion is expected ion. This is one way to show redox reaction using a net ionic equation. Now answer the question, which is reduced in the reaction. You look for the species on the reactant side. In redox reaction, we only focus on reactants, which is reduced, which gain electron. Silver is going to silver metal. Therefore, silver is the one that got reduced. Therefore, answer is this. It's not silver. You are not looking at the product side. It's not silver. One that got reduced is this. One got oxidized is lead metal. Therefore, answer is B. It's pretty easy to figure out from equation. Looking at the metal ions, which one got reduced, which one got oxidized. If you look at the same equation, what is the oxidizing agent? We talked about in the previous slide, oxidizing agent is one that got reduced. One that got reduced is silver. Therefore, oxidizing agent is also silver. Why? This got oxidized, this got reduced. Reduced in the reaction is lead. One that undergo reduction is also the oxidizing agent. Answer is B. Do you have any questions? You guys okay with everything here?
Yes, sir.
All right. Which is reducing agent? Now, reducing agent is one that got oxidized. One that got oxidized in the same question, same reaction, is lead. Lead is the lead got converted to lead 2 plus. Electrons is lost from the lead. Therefore, lead is the correct answer. You pick up the reactants. Could you turn off your mics? Okay, lead is the one that got oxidized. Therefore, lead is the reducing agent, A. Now you go on over some of the examples describing redox reaction. The single replacement reaction redox reaction. Single replacement is one atom of element is replaced by in a compound, replaced by another atom of an element. If you look at this picture, plate of copper is placed in a copper sulfate solution. This is the same thing we talked about in previous description. The copper gets reduced to copper metal. That black color is coming from copper ions in the solution, copper 2 plus, aqueous, get converted to copper metal. So zinc metal get dissolved. So zinc get dissolved into zinc 2 plus. It takes place simultaneously. Some zinc metal dissolved. Some copper ion is deposited on this is zinc metal plate. The black color is coming from deposited copper ion, copper metal. The blue color of the copper sulfate solution, gradually you see this blue color is changed to a lighter. Therefore, copper ions. Blue color is coming from copper ions. Copper get deposited. Copper ion get deposited. This is the same equation we looked at previously. This is what takes place. Now here is the question. If you put the zinc in copper sulfate solution, reaction takes place directly. In redox reaction, one thing that takes place is electron transfer. This is direct electron transfer from zinc metal to copper 2 plus. Therefore, it's not useful. All what we trying to do is create a current so that we can do useful things. Normally, redox reactions are used in batteries. A battery is a source where you can use electrical current to light up a bulb or do other things, run a motor, electrical energy. So how we harness this electron, that zinc directly gives to copper ions. That useful electrical energy is obtained. This is how we do it. You separate out two electrodes. This is the same reaction, copper sulfate react with zinc, directly produce copper metal and zinc sulfate. Let's look at this little more detail before we separate out this redox reaction into half reactions or electrodes. The oxidation number of a metal atom, for example, zinc, is 0. Oxidation number is the charge on the metal. Zinc metal don't have charge, therefore oxidation number is 0. Copper ion here is, we know sulfur is 2 minus, therefore copper is +2. Therefore, oxidation number of ion is the charge of the ion. Oxidation number of zinc is 2+. This is a copper metal, neutral copper atom, that's 0. Another way to tell you that oxidation is loss of electron here, zinc metal to is an increasing oxidation number. If an atom increases oxidation number 0 to +2 is an increase. That's oxidation. If metal 2 + 2, 0, that's copper. That's reduction. We also use oxidation number, change in oxidation number to indicate oxidation and reduction. Now let's see how you separate out these two electrodes and transfer electron between the electrodes, create an electrical current. Oxidation number is the charge on the element. You look at the formula, figure out the charge. That's the charge number is the oxidation number. If its charge is +1, oxidation number is +1. Here, zinc metal loses electron to copper. That's the oxidation half reaction. That's one of the electrodes we are making. We write down this is zinc. This is zinc sulfate solution. You put in a beakers to create a half reaction. Zinc in zinc sulfate is oxidation half reaction. Then you put the copper in the copper sulfate solution. You are separating out. That's oxidation half reaction. That one is the reduction half reaction. It takes place when you directly electron transfer. If you separate the metal, that's the reduction half reaction. Copper here, copper sulfate, That's the reduction half reaction. Now you have separated electrode for redox reaction. Now what you do is create a electrochemical cell. Cell is a battery where electrons are transferred. Electrochemical cells. The electrochemical cells in the liquid form, which has liquids like copper sulfate and zinc sulfate, are called galvanic cell or voltaic cell. Voltaic cell is the correct name, not the galvanic cell. Oxidation reaction could be turned into a voltaic cell where solutions of metals are dipped in the solutions of salts, metal salts, and create a cell. That's zinc to copper. This is the two solutions. That's oxidation half reaction. This is reduction half reaction. You simply connect the zinc metal on the previous diagram, isolated solution of zinc sulfate and zinc, electrical wire passing through the, connected to the bulb right here to the copper metal. Now electric circuit has to be continuous. We use device called salt bridge, which contains certain ions which keep the electrical connectivity between the two solutions. Therefore, when this is connected, zinc gets oxidized. That's the oxidation half reaction, zinc. Copper gets reduced. Zinc go to zinc 2 plus, 2 electrons. So this allows us to use electrical current. Cell is a device that harnesses flow of electron in an electrochemical cell. This is called a voltaic cell. This is the first battery they ever make. Later batteries these are liquid containing like copper sulfate, zinc sulfate. These are the combination of metal and the solution. So when you combine these two, this is the oxidation in one electrode, oxidation takes place. Reduction takes place in the other electrode. Oxidation where oxidation is taking place, electrode is called anode. Where the reduction take place is called cathode. Therefore, negative end is the anode in a cell. Cathode is the positive end. When you have a cell, you represent cell by this. This is the positive end. That's a negative end. Cell has a potential to flow electrons. Potential to flow electron depend on the constant type of the elements we use. Therefore, oxidation reduction reaction could be converted to a cell. There are dry cells. Dry cells don't have liquids. They have a paste. Most of the common batteries are dry cells. So this is how you convert redox reaction, oxidation reduction reaction into a voltaic cell. Now, galvanic cell is another name for voltaic cell. I said that in the previous slide. Most common name is voltaic. This is a diagram where there's another cell made out of zinc sulfate solution, silver nitrate solution, silver sulfate solution. You use the same anion for spectator ion. This is the oxidation half reaction. Remember previous slide. Reduction half reaction here. That's the anode. That's the cathode. Electron flow from, this is the negative end, positive end. Electron flow from negative end to the anode to cathode. Now the current is opposite of electron flow. Current flow from cathode to anode. In a cell, electron flow from cathode to anode to cathode. Current flow from, this is current. Now let's answer a few questions about this cell. The solid zinc electrode. Which is the cathode in the galvanic cell. Cathode is found on the right side. Normally, conventionally, anode is written down in the left side. Right side is silver. Therefore, cathode is cathode. These are the electrodes, are the metal rods. This is the cathode, electrode of the cathode, electrode of the anode. Therefore, silver is the cathode in the electrochemical cell given here. If the question of us, what is the anode of the galvanic cell? Anode is zinc, solid zinc electrode. Now, if the question was asked, which way the electron flow in this galvanic cell? Electron flow from cathode to anode to cathode, this way, right here. Therefore, zinc to silver. Current flow from silver to zinc electrode. So there are a few questions we can ask based on the galvanic cell given. In an electrochemical cell, anode is, let's look at the choices. That's the correct answer. We told you in an electrochemical cell, like a galvanic cell, right, in this case, electrode at which oxidation takes place is anode. Electrode at which reduction takes place is cathode. Therefore, answer is the A. The material used to connect the two-half reaction is not the answer. This doesn't make sense either. Never metal. It is going to be a metal most of the time. Therefore, answer is A. In this electrochemical cell, reduction half reaction is reduction takes place on the left side. Therefore, this is the previous galvanic cell, where zinc is placed in zinc and zinc sulfate, copper sulfate. That is the diagram in the previous galvanic cell between. In that cell, reduction half reaction is copper. Reduction is written on the left side, right side. So copper is that's the reduction half reaction. Do you guys know this has to be connected with the salt bridge, which prevents the direct contact of two solutions, preserve the cell circuit. Therefore, answer is A. Do you have any questions?
No, sir.
All right, good. Now we go on over oxidation reduction reactions for ionic compounds, where it contains metal and metal ions. We can use the loss of electron is oxidation, gain of electron is reduction directly. But certain oxidation reduction reaction, like combustion reaction, where the compounds involved are covalent compounds. The ions are not clearly seen. Therefore, we deal with oxidation reduction reactions of covalent compounds separately, just as we discuss bonding differently. Oxidation reduction reaction of covalent compounds require different approach. there are no ions directly seen in covalent compound. Therefore, it's hard to figure out which one is being oxidized, reduced. For example, if you take methane, this is combustion. In previous slide, at the beginning, we defined combustion as a oxidation reduction reaction. But you cannot see ions here. Therefore, we use different terminology, alternative definition to describe the redox reaction. Here is what we use. Normally, oxygen is more electronegative. Therefore, what takes place is oxygen combined with methane form carbon dioxide and water. If a compound gains oxygen or loss of hydrogen, that process is called oxidation. Now, alternative description for loss of electron is gain of oxygen. When a compound gains oxygen, the carbon atom here gives electrons to oxygen, form oxygen. Therefore, it's equivalent to loss of electron. Oxidation in ionic compound was loss of electron. In organic compounds, covalent compounds, right here, loss of electron is gain of oxygen. Loss of hydrogen is another way to describe the oxidation. So in this case, this compound carbon gains this compound, this is oxidized. This is gain of oxygen. This is loss of hydrogen. There are 4 here. There are 2 here. Therefore, this process is an oxidation. Reduction is defined for covalent compound, loss of oxygen or gain of hydrogen. Now, when you look at covalent compounds and their reactions in redox reactions, you look at whether substance gain oxygen. That's oxidation. If the substance lose this CH4 lost hydrogen, carbon dioxide don't have hydrogen. Therefore, gain of loss of hydrogen is oxidation. Gain of hydrogen is reduction or loss of oxygen. These are alternative descriptions. Let's look at this in more detail. As we talked before, gain of oxygen is oxidation. Loss of hydrogen is also oxidation. The loss of oxygen is reduction. Gain of hydrogen is also reduction. We looked at CH4 in the previous slide. Oxygen, water as a product, carbon dioxide and water as a product. If you look at carefully, this compound gains oxygen. It lost hydrogen, therefore oxidation. There's no hydrogen here. That's the terminology we use. Gains oxygen, loses hydrogen, that's oxidation. Oxygen gains hydrogen. Therefore, it's reduction. In this case, oxygen is reduced. Therefore, it is an oxidizing agent. Combustion reaction, oxygen is the oxidizing agent. This is the reducing agent. The fuel you burn is the reducing agent. So we still describe oxidation reduction reaction. Which of the following oxidation is oxidation? This is the alternative description. Oxidation is defined as loss of electron in metals and metal ionic compound. Loss of hydrogen is or gain of oxygen. These are all description that applies to oxidation. Which of the following is reduction? Gain of electron is correct. Loss of hydrogen is not correct. Gain of oxygen. Not correct. Therefore, answer is A. Which of the species in the covalent compound combustion of formaldehyde? Which species? One that combined with oxygen, this has more oxygen, gain of oxygen. This is the one that is oxidized. Oxidizing agent is oxygen. Species oxidizes formaldehyde. Normally, you look only on the reactant side. Reactant side is for CH2O plus oxygen. You don't look at this side to figure out oxidation reduction. You hold your grounds to the reactant side. Therefore, answer is A. In which of the species is reduced? That's oxidized. That's oxidized. That's the one. The other one should be reduced. It's the oxidizing agent. Oxygen is the correct answer. B is the correct answer. Which of the following are the products of incomplete combustion of hydrocarbon? such as methane. Normally, hydrocarbons, when they come react with oxygen, which we call combustion reaction, produce carbon dioxide and water. But that's the complete combustion, carbon dioxide and water. But incomplete combustion produce carbon monoxide and water. Hydrogen peroxide is not produced. This is complete combustion, carbon dioxide and water. Normally, they're asking for incomplete is this one. Therefore, correct answer is A. Remember, if you burn natural gas, if you start your car in the garage with garage door closed, it creates incomplete combustion of fuel, carbon monoxide and water. That's called incomplete combustion. That can kill you if you start your car in a closed garage and stay around. Which of the following is true of respiration? We talked about it. Respiration is redox reaction, where glucose is oxidized in oxygen to produce carbon dioxide and water. That's what the respiration is. Respiration produces energy. It is the conversion of iron to iron oxide. We never said that is respiration. Respiration has something to do with glucose being converted to carbon dioxide and water when glucose react with oxygen. The conversion of colored compound into colorless compound. That's not respiration. Production of energy in humans and animals. That's how we produce energy. Respiration is conversion of glucose to carbon dioxide and water and energy. Energy in the form of ATP. That's the correct answer. It is the generation of electricity in a voltaic cell. That's not respiration. Voltaic cell is a different issue. Therefore, this is not correct, this is not correct, this is not correct. Therefore, C is the correct answer. Which of the following is true of most bleachers? Swimming pool use chlorine tablets. The chlorine tablets produce chlorine, free chlorine, when dissolved in water. These are highly electronegative elements. Oxygen is also highly electronegative. Therefore, oxidation is combustion involve oxygen. Chlorine also used as oxidizing agent. It oxidizes using chlorine. To clean up water. They are both reducing agent and oxidizing. In bleach, chloride solution, chlorine is the oxidizing agent. Therefore, answer is B. Now we're going to answer in general redox reactions, questions on redox reactions, oxidation, reduction reaction. What is reduced in the reaction? Silver is reduced. You look at the reactant side, left side. So silver is the one that is reduced. What is found on the left side is you have to use the whole thing. Silver, iron, aqueous. B is the correct answer. What species is oxidized in the covalent compound, formaldehyde? That's the first one. This is the one being oxidized. So A is the correct answer. Look like we did this problem before. Oxidizing agent is one get reduced. That's the one that got reduced. Therefore, answer is B. Reducing agent in the reaction. Lead got oxidized. Therefore, it is the reducing agent. A is the correct answer. We've gone over redox reactions. We talked about general definition of reduction and oxidation. So now we're going to change the topic. The next topic is chemical calculations using chemical reaction. When you use chemical equations to do calculations, it's called stoichiometry. Now, let me tell you about this. When you do a chemical calculation, you use chemical equation. What chemical equation represents is atoms, molecules, and ions. Normally, those are the chemicals we think of in the chemical reaction. But when you do chemical reactions, we have to measure amount of reactants and products. Normally, we start with grams. That's a common unit in metric system, grams. The grams are not directly related to number of atoms in the formula. That's where the grams mole conversion comes in first. To do the stoichiometry, first you have to find the moles of compounds in the chemical equation. We can use molar mass to convert grams to moles. A molar mass is obtained from adding up all the atomic masses in the formula in the periodic table. Molar mass is given as AMU. In the periodic table, when you add up masses, the total mass of the formula in order is expressed as AMU, atomic mass unit. Atomic mass unit is also equal to grams per mole. Therefore, if we get the formula mass of water in grams per mole, you can use that as a conversion factor, formula weight in grams per mole, to convert grams to mole. So let's see how we do this. Before do the chemical calculation using a chemical equation, you need to convert grams to moles. How you convert grams to moles is grams divided by formula mass, which is given in grams per mole. Therefore, you get the moles. If the molar mass, where molar mass is used as the conversion factor. If you want to find out moles of water, 36 grams of water, how do you convert it to moles? Before doing the calculation in chemical equation, where moles is the practical unit for the amount of substance. Mole is the amount used in chemical equation. So you calculate 36 grams of water and find out the moles of water. What you do is you take the 36 grams here and use a molar conversion factor. This is the 1 mole of water is 18.0 grams. This is the factor label method. They cancel out. You get 2 moles. Then you can use 2 moles in the calculation. You can also calculate it back. If you know the moles of water, you multiply grams divided by formula weight is the first one. Moles to grams conversion. Therefore, moles multiplied by formula weight is the grams. Here is the moles. So you can convert between grams of the substance in a certain chemical and convert and calculate the moles of the substance by dividing grams with formula weight. If you know the grams, if you know the moles, that multiplied by formula weight gives the grams of the compound. Therefore, stoichiometry is done by converting grams of a substance to moles of substance. That's what we discuss in this chapter, this slide. If you look at the formula weight of a compound, how do you get the formula weight? You add up atomic weights in the periodic table, which is given in AMU or grams per mole. If you calculate the formula weight using the periodic table, the value you get, sum of the weights, has the units of grams per mole. We never use atomic mass units. we use grams per mole. If you look at sodium chloride, how do you get the formula mass? You add up sodium. There's one sodium here, one chloride here. Therefore, add up to 58.5. That's the grams per mole units. Nickel hydrate, nickel hexahydrate. That's hexa. Nickel has, this is the formula of the compound, type variable charge cation. Nickel can have nickel 2 or nickel 3. You add up one nickel atom. Two chlorides and 12 6 water molecules. You calculate the formula mass. So this is the conversion factor that is used to convert grams to moles of any of the sodium chloride or nickel hexahydrate. These are for ionic compounds. Second is for molecular compound. It's the same thing. You add up the atomic masses in the molecular compound, you get 18.0 for water. This is aspirin, one of the compounds we use for headaches. It has 9 carbons, 8 hydrogen. You added up 4 oxygen. The molar mass is 180. That's how you calculate formula weight. Formula weight can be used for both ionic and molecular compounds. Sometimes formula weight is same for ionic compounds and molecular compounds. But molecular weight is used for covalent compounds. Molar mass is another name, general name, mass of 1 mole. 1 mole is called molar mass. Moles to grams conversion is used to get grams or mole. This is the conversion factor. Therefore, conversion factor comes from formula weight, molecular weight, or molar mass. Let's finish this slide. What is the molecular weight of sucrose? This is sucrose. You add up 12 carbon atoms, 22 hydrogen atoms, 11 like in here. This is, therefore, answer is this. This is how you calculate formula weight or molecular weight. Barium phosphate. This is barium's atomic mass. This is phosphorus. This is oxygen. You count the number of barium atoms, it's 3. Phosphorus is 2. Oxygen is 8. You get the mass. The answer is which of the following compound has the largest formula weight? You added up all the masses. We looked at here. Formula weight is 39 here, 35 here, 23 here, magnesium. So when you calculate that, potassium chloride has the largest mass. Sodium chloride is not. So answer is A. I'm going to finish the class for today. Do you guys have any question?
No, sir.
All right. Just go over the material
Okay.
and
Okay.
I'm going to have the next class on Monday.
Okay,
Probably we could finish chapter 4 on Monday. Then
Okay.
we're going to have a review and then we can have the test on October 11th.
Okay. Okay.
All
Thank you,
right.
sir.
Thank you. See you guys later.
Bye, sir.
All right. Have a good day.
Yeah, you too.